that in a little bit. So for me, for example, I'm working on my iPad, and so once I logged into WebAssign, then I got the ebook, and it just shows up, and hey, it looks the same. Right, and so it's a much cheaper option. I know a lot of people like to have the hard copy, and I am pretty sure that there are hard copies in the library that you can borrow. Okay, so if you're working through it, but it's just nice to have an ebook at least at home, and we will be using WebAssign for assignments. Okay? All right, I better start making some notes here. This is crazy. Also, one more name tag. Okay, so I do things a little bit differently all around. No, not, well, yeah, kind of. So what I do for my classes is I record them, okay, so, and then I post them on YouTube. So if you miss a class for whatever reason, or if you want to review a class, maybe we went too fast, maybe you didn't get caught up in your notes and you decided to just sit back and watch the lecture, that's fine. I know that sometimes that's the best way to learn for people. Okay, so I want to remove the stress of getting the notes down and just kind of learning as much as you can in class. And so I give you all the lectures. They'll be on YouTube. And so the recording is going to be just whatever's on the screen. So it records my screen and my voice. And so sometimes there'll be things. I love this. I was in this room yesterday morning and I found this and I cannot wait to use it. Right, so if I'm pointing things out, then it might be a little bit hard on the recording, but other than that, I think it's pretty good. Okay. And so, so the lectures will be posted on YouTube. Okay. All these notes that I write on here, I'll save as a PDF and I post those on Moodle. Okay. And so you'll have those notes written out as well. That said, a really good way to learn is to write out the notes, right? But maybe not just blindly, right? So when you're just trying to follow me and trying to copy down what I'm saying, that might not be that helpful, right? But I try to give you as much as I can, okay? So you'll have the notes, you'll have the lecture recordings, and then also, I record using Zoom. It's basically Skype or whatever you want to call it. It's a meeting room. And so I've got this meeting room set up always. Okay? And so if you wanted to join from home, right, it is an 8 a.m. class after all, right? And so you can absolutely join in from home. And you just join this Zoom room. And I'll talk about how to access it in a little bit. Okay? So lots of fun things, maybe weird things. I think I'm the only one who has this kind of setup. I think it's worked out in the past. All right, so let's do some contact information. The only bummer is when I write on my iPad, I have to sit down. So I'm way down here. I know, but I just want to be up here. I've tried the slanty thing, but I just get carpal tunnel right away. It's really bad. So anyways, here I am. So I am Emily. Lee. 5 E's, can you believe it? 9 letters, 5 E's. It's crazy, right? I used to be Gustafson, so I guess Lee is a little bit better. A little bit easier, at least. My office is just downstairs, C104. So I'm there most of the time. Okay, so if I'm in my office, just stop by. If you have a question, then just see if I'm in my office. If I'm there, you can stop by. I have office hours. I mean, because I'm here so much, I don't know. Sure, yeah, I'll be there for sure those 2 hours a day. But I'm here more than that. Okay, so C104, that's my office. My email follows the typical structure, ely@okanagan.bc.ca. I'm gonna give you guys my cell phone number because, well, there's a couple of reasons. 250-864-8386. So what I find, if you're working on a question, then it's just easier for you to send me a picture of what you've done, and then I can easily just send you a picture of kind of where you went wrong or whatever, right? And so for me, communicating by text is just a little bit quicker than an email. For me, even sitting down to, even if I'm on my phone, just to write an email feels it's just harder. I don't know what it is about it, right? And so so if you text me, then at least we can just kind of get into it right away, right? Oh, hey, how's your day? Blah blah blah. No, pardon? Exactly. Well, I mean, they go to the same place, so like they go to my phone, but my email feels less important. Kind of like, yeah, Pizza Hut and you. No. So for me, if you want to get a hold of me, then definitely text me because it's a little bit more effective. Who doesn't have a name tag sheet? If you don't know what I mean, then you probably don't have one. All right. So, that's working. Cool. I'm still debating whether I should keep these and bring these to class every day. Then I'll know if you didn't come the next day. Hey, I've still got 3 name tags. Or if you guys should bring them, we'll see. Still. But anyway, so if you have a question, then absolutely just reach out right away. I do not want you to be struggling too long. I do want you to work on problems, right? Because this is the type of course where you have to really work on these problems, and you'll have all the tools from class, even though it won't feel like it a lot of the time, right? Because you'll need to kind of string them together, right? And so it will be kind of a high thinking course, of course. So there's my contact information, and then you can join class remotely using Zoom. I think it will ask you to download some sort of app or whatever. You can do it on your phone or whatever. Shouldn't take that long. It shouldn't be that big. But then you should not have to sign up for an account. You should just be able to join the Zoom room, okay? And so join class remotely. Using Zoom. And our Zoom, I want to say Zoom ID, I think it's called, or meeting ID or something like that, is just my cell number, 250-864-8386. So they're the same. So this Zoom room is open all the time. And I do get a little email telling me if someone's gone in there. That's fine. If we don't have class, then I'm going to ignore it, right? Because sometimes people will just kind of click the link and go check it out, or just kind of test it out. So I'll ignore those. But if you do want to meet in the Zoom room, if you have a question and you're at home and maybe I'm not here or whatever, we can do that as well. Okay, because sometimes it's easier to just show my screen. Okay, so that's Zoom. I'm going to show you guys our Moodle page that I'm definitely still working on, but new Moodle, what do we think? I know, right? I was hoping it would look a little bit better. It looks better than the old one. But I really had a heck of a time finding some of this stuff and some obvious stuff like how to edit this page. Like, where do I go? So anyways, here we are. Welcome to Calc 1, it says. I wrote that. So handy. Cannot wait. So again, it's just got all my contact information. And then I randomly picked office hours, Mondays and Wednesdays, 10 to 12. But like I said, anytime I'm here, or even if you see that I'm not here and you need to see me, that's fine too. And then I've got the Zoom ID there. So we've got our grade breakdown. You are enrolled in a lab, not with me, because I don't have any calc labs, but that's okay. They'll just be run by your lab instructor, and at the end of the term, they send me your grades, and then that'll be 10% of your grade. Okay? You'll be using Maple in the labs. If you haven't used Maple before, which is very likely if this is your first time taking calc, then it's pretty fun once you get used to it. Okay, so like any programming language, right? The initial kind of, I don't know what's going on, that's going to last a while, right? But you just have to keep working at it, and eventually you'll just see that it's just a big calculator, right? With instead of visible buttons, you have to tell it what to do, right? But it's just a calculator. So, so that's going to be 10%. I am just saying, okay, well, however you're evaluated in the lab is by lab instructors, so you'll have to go to the lab to see them. Oh, I will make a note here. There are no labs this week. Kind of hard to have a lab before we've had class, right? And so just as a standing order, there's no labs in the first and last week of classes. And so no labs this week. Although I sent out an email to everyone who's teaching the labs just to reconfirm. Does anyone have Doug Birtwistle for their lab? Anyways, I guess he had gone anyways. And people had been there.
We have been there.
Yeah. So anyways, no labs this week. Take a break. All right. So the assignments are going to be worth 10% of your grade. That's when we're going to be using the WebAssign, right? And so, I've got a little slideshow that they sent me, so we'll walk through that. But the WebAssign, I'm not one that likes to make you buy a textbook, but this will be worthwhile because the WebAssign, it's pretty cool. I mean, it tells you, I think there's videos, there's little help hints, there's like, it can really help you as you're working through these problems, right? And so instead of you working on an assignment for I don't know, 10, 15 hours, you hand it in to me, and then a week later or whatever, you get it back, and there's no connection there, right? And so for that reason, that's why we're all moving just towards WebAssign, because it is so kind of quick feedback for you. It is $99.95 through the bookstore, right? And so I would definitely recommend that you buy the WebAssign, but just the access code with the ebook. And then because the hard copy, this big brute, is $203. and 99 cents. It's on sale. No. This access code that you're buying, is anyone planning on going into Calc 2? Get your calculus saver. Go for Calc 4. Then you're done. But what's fun about Calc 3 and 4 is it's just Calc 1 and 2 all over again, but just more variables. Anyways, I know, spoiler alert. Sorry, guys. No, but what's nice about this textbook, and I'm holding this one, but I mean the ebook and the access that you're buying as well, is it will cover Calc 1 and Calc 2, right? And so that WebAssign access that you're buying would be for this course and Calc 2, okay? And another one if you decide to do it, right? So with your access point, you get 3 terms of use, right? And so I think that's pretty good. So you can take it again just for fun. Not happening, huh? So we will do sort of weekly assignments, right? These are going to be pretty big assignments, right? And so they will require a lot of time. They are 10% of your grade. I hate to give it as an option because I want you to succeed, and the way to succeed is to practice, practice, practice. If you decide to forfeit those 10% of your grade because you don't want to buy the access point, I don't know. That's not really my business, right? So, but it is 10% of your grade, and it should be a pretty solid 10% of your grade, right? If you're doing these, you'll have 5 attempts and just kind of to work through things. So, should be pretty solid.
Are they hard copies of story, or are they online?
They're online.
Oh.
Yeah, yeah. So it's pretty clever. It's way more clever than anything we could ever build in Moodle, and so that's why we moved towards it, because it'll identify where you're going wrong, and just kind of like, hey, how about, do you want to read this section of the textbook, this specific section that's going to help you solve this problem? Cool, right? And so it'll just really be helpful. And so there are going to be 4 tests. What? That's crazy. I would call them maybe quizzes instead, because there's so many of them, right? They'll only be in the first 50 minutes of class, and then we'll do a lecture portion after, right? And so for the last hour or whatever, right? And so the reason for that is because we have the nice 2-hour block, but there is I think there's a section that only has 1 2-hour block and then 50-minute blocks. I can't remember what the setup is, but because we need to be on par with the 50-minute block, I can't give you 2 hours to do a 50-minute test. So to keep them all the same, we do 50 minutes, and then we do lecture after. So I've got those test dates here. First one is going to be January 28th. Second one, February 25th, March 17th, and then April 7th. Right. Just the 4 tests, nice and spread out, kind of less stress, hopefully, right? 1 in each month. How nice is that? I know, April shouldn't be there. It's almost over in April. And then, oh, I'm trying to scroll on that one. That's just showing the screen. And then, of course, the final exam, it is going to be 40% of your grade. I don't know when it is yet, but as soon as I know, I'll post it on there. And you'll know because the whole campus will be buzzing. Final exam schedule's out. Blah, blah, blah. That's all we wait for. Okay, so next stop, I put this link to the lecture videos on YouTube. So it'll just take you to my channel. Look at me, 51 subscribers and counting. So pretty good. You guys are probably way better YouTubers than I am. but all I do is I just download the video and upload the video, and that's all I'm doing. So, so as they get posted, right, so there's my Stat 121 from yesterday. And I'll just keep kind of funneling them in. Right. But you can search through them. You know it better than I do. Anyways. Oh, as far as reaching everyone, for example, if I had to cancel a class, right, that's the only time that I need to get a hold of you guys so you don't show up unnecessarily. Not that I anticipate canceling class, but it can happen. Anything can happen. I am going to have to use the announcements button here. So just make sure that your personal email is hooked up to your weird Moodle email, right? And so if you need help with that, you can go see IT because I don't know how to do it. I know it can be done and should be done, but that is how I'm gonna get a hold of you guys, right? And so what I'll do, and I have to remind myself, is I'll send out a test one tomorrow, maybe today. I don't know when it's gonna be. When will I remember to do it? Just to make sure that you got it. Only because I said I would do it for my other class yesterday, and then I forgot to do it. I still have till tomorrow. So. Any questions so far? No? Okay. So, today I did put, you do not need to purchase the textbook before the first class. We will discuss the textbook in class, right? And we'll talk about it a little bit more because I've got those setup slides. But first, let's just go through how I've laid out the Moodle page. It's pretty straightforward. I'll do it by week. I think I only did the first 2 weeks for now, just to show you guys. So for each day, I'll tell you what we're going to be doing, and then I'll post the notes after class. Right? And they'll just be there, and anything else that I've given you or that you need. Any due dates through WebAssign? Unfortunately, it's not linked to Moodle, and so there's not going to be a Moodle reminder, right? So it will be on you to remember those due dates, but I will highlight them like that in whatever block it's supposed to be in. Okay? And so we've got this diagnostic quiz, which is due January 17th, which is what, next Friday, I want to say, at midnight. So I've made them all due at midnight. And so the diagnostic quiz, I'll count as an assignment, right? It's just to help you see, kind of identify where maybe you need to read up on some stuff before you get into the course, right? And so try the diagnostic quiz. It's okay to have to kind of refresh on some stuff, right? But if it's feeling completely not doable, right, then that's a pretty good gauge. Okay? Very important, and I can't believe I forgot. For the WebAssign, you get 2 weeks of free access, right? So if you're not sure if you're going to stay in the course or whatever, right, or maybe just use the 2 free weeks of access, then just log in. You can make your WebAssign account. It'll keep your assignments with your account, even if it's still the free one. And then if you have decided to stay in the course, right, then you can go out. You can buy the WebAssign, right? You have it. Okay. So I'll make a note of that here. You get 2 weeks of free access to WebAssign. Right? So you can try that 2-week trial. And then it's mostly if you decide to drop the course, then that's kind of no harm, no foul, right? So that's good. Okay, I'll talk you through those setup slides, but first, just kind of run you through the course outline. It looks the same as what you always get. I don't print them. It's 5 pages that you'll never read. So it'll be on Moodle. If you want a printed version, let me know, and I can absolutely print it for you. But I haven't. So it does say that the required text, but I should change that to just the ebook, right? It's not a physical textbook. So like I said, this book covers Calc 1 and Calc 2, right? Which means that we're actually only going to work through chapters 1 through 4, right? Cutting out a couple of sections, but not too much, right? And so let's see, just so we can have some goals here. Okay, we're into chapter 5 already. So we're only doing that much of the textbook. So it looks bad, but it's not that bad. Not as bad as it could be. Right. And so today we'll just work through 1.1. I was hoping to get to 1.2, but save it. So we'll just kind of plug away through chapter 1, which is basically just a pre-calc review, right? And then we get into chapter 2, which is the new material. Okay? So the learning outcomes, although probably not, they don't mean anything to you now, right? It is nice to be able to look back at the end of the course and look through the learning outcomes and just know that you've accomplished all those things, right? Some of them are kind of vague, and so we kind of go into it more or less, right? But as a rule, these are all the things that you'll come out of here with, okay? Which is pretty good for studying for the final too. Like, oh, here are some key things that we as a department have decided you should take out of this course. Well, it should probably be on the final exam. So like I said, labs 10%, assignments 10%, tests, there's 4 of them worth 40% total, right, 10% each. And then the final exam is 40. Okay. And so, like I said, I'll just reiterate, I have nothing to do with the labs. I've taught the calc labs before, so I know what's going on, but as far as these labs go, it's all to your lab instructor, right? And so you're in their hands. And the assignments we talked about are going to be done in WebAssign. And then here I've specified that the tests are in the first 50 minutes of the class that the test is on, and then we follow it up with some lecture material. Okay. The final exam is cumulative, so it will be all the material, right? And for our department policy, the main thing that I want to kind of draw your attention to is that you do have to get at least 45% on your final in order to be able to pass the course, right? So it doesn't matter if you would pass with 40% on the final, you have to get at least 45 in order to be able to pass, right? I don't think it's that unreasonable, right? After a whole term of learning this stuff, can you sit down and produce 45% of the material? Yeah, you can. So I'll also say that the WebAssign assignments, once they're due, they're due. I'm not going to open them back up, right? So you will want to keep track of those due dates. And I'll post them on Moodle as we go. And important dates, you probably know them already, right? But the main one would be the last day to withdraw or drop or enroll or whatever is January 17th, so that's next Friday. And then for some crazy reason, you have until March 6th to withdraw with a W. That's forever away. Crazy. And then the rest is history. College policies, don't cheat, be nice to each other, be nice to me. We'll be all good. No, but it's all there if you want to have a read. Okay. Any questions about that? Okay, so so these are the slides that they sent me for the setup. I haven't used WebAssign before because I didn't teach any calculus term, so I'm learning it too. Luckily, Steve sits right behind me and he's the WebAssign expert, so which is lucky for you guys too. Okay, so here's their plug. WebAssign's awesome, blah, blah, blah. You can read it later. Over 1.5 million students use WebAssign each year. That's crazy. What is really cool is when we pick the questions, it'll tell us how many people have attempted that question and how many people kind of managed to do it. It also tells us how long it should take, right? And so on average, you know, this question takes 11 minutes, and then we can kind of see how long of an assignment it is. So that's how I know that they're pretty long. I'll tell you guys exactly when I check it. How about that? Okay, so main deal is that you get the ebook as well, right? So that's really nice. You will just sign into your WebAssign, so it will be separate from your Moodle, but I'll post the link to it, and it shouldn't be that bad. Right? So, and I haven't asked, but I'm sure it's through the app as well. So you could probably just have it on your app, on your phone, on an app. I don't know. Okay, so this is the link that I'll post, right? And so we're gonna visit this website, and it's gonna take us to this page, unless you have a sign-in already, right? So if you've used WebAssign already in the past, then you have a sign-in, and you can probably just log in, and it's all good. But other than that, you'll go up here, where it says enroll with class key, right? So our class key, and I'll post this kind of clearer on Moodle as well, but I didn't want to put a ton of weird information on there right away before we talk about it. So, so now you'll know, oh, that's just how to sign up for WebAssign. Oh, that's just our class key, right? And so our class key is openhugging.bc, and then it's 30009753. So I'll post that number as well. It'll ask you, hey, is this your class? Hopefully it is, right? So it should say Math 112 001 Emily, for example. Yes, this is my class, great. So it's not until then that it'll ask you to create a WebAssign account. So now you can either, again, sign in, or you can make your account. And I think we all know how to make accounts. All right, so you can either select create an account or sign in, depending on what your situation is. And then you create an account, and then here, I'll zoom in on this because I feel like this is important. It tells you your grace period, so that's your free trial, right? And so, so after you've created your account, then you're going to be logged in. You have a 14-day grace period, like I said, so 2 weeks. And if you don't have an access code, right, so if you're deciding to not enter it quite yet, then that's fine. Then you can just say, oh, I'm going to enter it later, right, if you're just going to use that trial, right? Or even if you come back to it with an access code in 2 weeks, that's totally fine, right? And say, okay, well, now I have an access code, and then you're going to click verify payment, okay? Here's the key thing, okay? If you buy it through the online here, you're going to pay in US dollars, right? And so if you go to the bookstore, then it's going to be in Canadian dollars, and it's going to be normal, and it's going to be fine, right? I don't think that there's a huge difference, but everything helps, right? And so that's why it's here in red, and I'm so glad they put that there because I had no idea. But do not purchase the access code through the website, go to your bookstore. And so it'll give you an access card, and you enter your access code. There you go. It's the wrong textbook. Close enough. So James Stewart, he's passed away now, but he's kind of like the rock star of calculus, especially calculus textbooks. He's produced so many calculus textbooks, and they're really good. That's why it's hard to go away from this one for calculus. So, and then you're all set, it says. So once you're in, you can kind of poke around. I've got the assignments set up there. As of right now, I'm pretty sure they're all due just at the very end of term. And I would be fine keeping them that way, but the only problem is that you wouldn't see the solutions until it closes. And so that's why there's going to be due dates, but it's also to keep you kind of on track, right? To kind of motivate you to keep going, right? Otherwise, it's too easy to just put off like 1,000 hours worth of homework till the end of term. That's bad. Okay, so once you're all set up, then you'll just be able to go to that link, hit sign in, and you'll be in. Right. So, like I said, I'm not the WebAssign expert. So if there's little things like signing in and signing up and all that fun stuff, then yeah, sure, we can kind of work through it. I think it would be really good for me to learn too. But if it's kind of bigger questions like, help, this question isn't showing, or it's showing up weird, or I can't see it on my phone, or, you know, like WebAssign questions, then you have to contact WebAssign themselves. Right? And I've heard that they're really fast at getting back to people. They have been for me, but maybe it's because I'm special. They're like, yeah, sure, you're going to use our stuff. Got it. But hopefully they'll be very fast. Okay. Any questions? No? Let's see here. We talked about tests. We talked about the textbook. It's pretty good. All right. So calculus, huh? Here we go. Here we go. No one wants to procrastinate with some questions? All right, here we go. We're gonna start. Let me see here. Oh, just make sure I didn't miss anything on here. Oh, well, this isn't important, but I'm counting reading break as a week because that'll be an easy win. Go straight from week 6 to week 8. It does make 14 weeks instead of 13, so I'm not sure what the difference is, but I guess that's how I operate. Easy win. Great. All right. So, hit me. Yes, it'll be in the course outline. Do you want me to just post a picture of the front, maybe?
Just because it needs to go to the bookstore.
Totally. And you guys know there's a used bookstore on Sutherland, right? So, so on Sutherland, there's a used textbook store. Yeah, because this edition is quickly going out of style. So we've had the 8th edition for a few years now. So I haven't been there recently, but I think you might have some luck. Right. So even if you wanted kind of a hard copy, then it should be doable. And maybe if you're looking through, if there's one with the WebAssign access that hasn't been used, then go for it. I don't know. I don't see what the problem would be. Problem would be if the WebAssign access has already been used. I don't know.
So you sign up for the WebAssign and you get the textbook?
You get the ebook. Yeah. Yeah. So so you won't have the physical hard copy, but I will double check because I'm pretty sure there are copies on reserve in the library. So if you're working here, then you could probably just take it out for the day and just kind of have a read through it that way, if you prefer a hard copy. But, cool. All right. So much housekeeping on the first day, but it's all fun. All right. No takers on the procrastination, huh? All right. Then we'll start. Section 1.1. So like I said, chapter 1 is essentially going to be kind of a quick paced review of pre-calc, just so you know all the things that you're expected to know, right? And then you can stress out about it on your own time. How about that? So, section 1.1 is 4 ways to represent a function. So we're going to talk about a function, just what it is, what can we do with it, how does it behave, right? Hopefully, you'll have heard of functions, worked with functions before, right? But every time that we talk about it, it just better. So 4 ways to represent a function. And I apologize, but my writing, although I've had like a month off of writing, it's not going to get that much better. A little bit better, small improvements, but overall, I'm sorry. I'll blame it on the iPad. It's so hard to write on here. It is, but so like I said, everything that we're about to do in calculus will be dealing with functions, right? So everything that we do will have a function, right? Here's a function, here's a function. And so everything we will do in calculus will deal with functions. Therefore, we will spend chapter 1 reviewing functions and models. Therefore, we will spend chapter 1 reviewing, oops, keeps jumping around, reviewing functions and models. So functions are usually represented as an equation, right? But there's more ways that we can represent a function. And so we'll just talk about the 4 main ways, right? And so a function can be represented in different ways. Oops. What the? Keeps hopping around. First, by an equation. This is probably how you're used to seeing a function. Or in a table. What we'll talk about in a little bit, but what you probably know is that a function, it takes some input and it returns some output, right? So we could easily put that into a table and say, well, at this time of day, the temperature was this much, right? At this time of day, the temperature was this much, for example, right? And so that would be a function, right? Because depending on the time of the day, right, that's going to tell us what the temperature would be or was at that point. So showing a function in a table also works by a graph is pretty handy, right? If we can show things like stocks, right? How they move over time, right? So time is the input, right? And then the value is the output, right? And we just see how it moves over time, right? And so that's a pretty effective way of showing that function, right? And then finally, in words, pretty vague, right? But sometimes that's how we talk about functions, right? So I think the example in the textbook, they describe the weight of shipping a parcel, right? And so, or the cost of shipping a parcel depends on the weight, but also the size. And so it just kind of blabs at you all the information. And then from there, you'll be able to calculate based off of the inputs what the cost should be, right? And so those are kind of the 4 main ways that we would represent a function. And we said that functions arise whenever one quantity depends on another. So functions arise whenever one quantity depends on another. So a part of this course is just getting used to more mathematical notation, right? And so we will be talking about definitions, and I don't just do those for fun, because for me, that's kind of like, oh, well, now I've given you that definition, so now you know that piece of information. And so, like I said, all the problems that you're going to be doing are not going to be exactly what we did in class, right? They're going to be kind of tying things together, right? But so you're going to be able to tie together definitions and say, well, if this is true, then this must be true, right? And so I know that this must be true, right? And so we'll start kind of our definition, our math definition journey with defining a function in kind of mathematical notation. So a function f is a rule. Wait, it is so finicky today. It's crazy. A function f is a rule that assigns to each element x in a set D exactly one element called f of x in a set E. Oops. In a set E. I'll clean that up. Okay. So all these definitions, I'll try to remember to put a, let's say, a pink box around them. Oh. So a function, right, takes some input, gives some output, right? It takes some input from a set D, which is the domain, right? And then it gives some output, which is part of the range, right? All the possible values of the output. And so we usually consider functions for which the sets D and E are sets of real numbers. Okay? So we usually consider functions for which the sets D and E, D being the inputs, E being the outputs, are sets of real numbers. Real numbers are just all the numbers that we know and love, right? So there are real numbers, and then there are imaginary numbers when we take the square root of -1, which we can't do, right? And so we don't deal with imaginary numbers until, I think, maybe Calc 3, I want to say, right? And so that's not on our radar. So we deal with real numbers, which are all just the numbers that we can think of, right? And so even things like pi, right? We know it continues forever, but it's still a real number. Okay? So the set of real numbers is denoted by, oh, I did not a good job there. It's kind of this fancy R with a double back. Okay? R, this is the set of real numbers.
So why do you say the set of real numbers, not just real numbers? What does the set mean?
So a set is essentially just a collection of elements, and those elements would be every number that we've ever known, right? So yeah, it is a set. It's the biggest set there is. It's infinitely large. But yeah, so it's still considered a set of real numbers. Okay. So that fancy R is going to be kind of a big player for us, right? Because we will be dealing with real numbers. Okay. Okay. So let's talk about the domain and then the range of a function, right? So the domain of a function is just all possible inputs, right? So all possible values of X typically. Okay. Domain is all possible values of X. Oops. Or all possible inputs. And the range, same idea, but it's all possible values of f of x, which is all possible outputs. And so all possible values of f of x, which are the outputs, right? The key is that it hinges on as x varies through the domain, right? So as long as x is in the domain, then we can talk about the range, right? But if we're using an x that's not in the domain, it cannot produce that f of x, right? And so all possible values of f of x, which are the outputs, as x varies throughout the domain. Oops. Varies throughout the domain. So, because it's not always obvious, right, this f of x notation, right, f is the function still, right, and then in the brackets we say, okay, well, what's our input going to be, right? And so f is the thing that transforms x into an output, right? But so f of x is read, oops, f of x and in general, right, if you've got something, a function name, right, and then in brackets some input, right? So for example, g of a is also a function. G is a function with a as the input, right? And so, right, this would be g of a, right? And so we give some input to the function and it returns some output. And once you're logged in for your free trial or reading chapter 1 by some other means, right, they've got all these fun kind of examples. Oh, it's a machine and you plug one in and it spits it out. And so if some of these aren't making sense, then of course the textbook goes into more detail, but this is stuff that you're kind of expected to know, or at least sort of vaguely remember. Right? So we will be talking a lot about the domain and the range, right? Especially the domain, right? And so let's just highlight the two main things that we need to remember for the domain, right? And those are just illegal math moves, right? We cannot divide by 0, right? You can try it on your calculator, it doesn't work, right? And that's because it's illegal math. We can't divide by 0. We also cannot take the square root of a negative number, right? It puts us into imaginary numbers, right? Which we're not going to deal with, right? And so, so for us staying in the real number realm, right, we cannot take the square root of a negative number. So those are the two main things that you're always going to keep an eye out for, right? And especially if you're trying to find the domain, right? Then okay, well, what makes me divide by 0? Anything that makes me divide by 0 is not in the domain. Anything that makes me take the square root of a negative number, also not in the domain. And so 2 important things, oops. 2 important things to remember about the domain of a function are, well, the first one is we cannot divide by 0. And the second is that we cannot take the square root of a negative number. Any input, right, so any value of x that yields one of these situations, right, cannot be in the domain, right? So we take it out of the domain. So any input that results in either of these situations cannot be in the domain. So I've got an example for the domain, right? But first, we'll just do a little warm up with functions and manipulating functions. And so, and I just steal these examples from the textbook. So example 3, if you're curious, if f of x is 2x squared minus 5x plus 1, and h is not equal to 0, I want you to evaluate f of a plus h minus f of a over h. So here we've got a fraction, right, and it's over h, and it's already saying, well, h isn't going to be 0, so you're not going to divide by 0, right? So everything is fine, right? We can go ahead. So give you a couple of minutes to work on that. I know, what a jarring way to start. It's a difference quotient, which I'm sure you've seen maybe. Or I should have said, you can chat it out. You don't have to work.
Is it 1?
It is not 1. Let's see what we got. I'll work through it. How about? I think what I was looking for. I was scoping out your names on the spot. It'll take me a while yet, but I feel like I'm off to a pretty good start. All right, so even if you're not quite finished, right, let's just start and talk about, okay, well, if I know in general what f of x looks like, right, then if I want f of a plus h, that means that I'm going to replace all my x's with a plus h. So wherever I see an x, I'm going to plug in a plus h. And then here is another function, right? Now I want f of a. So there's actually 2 kind of big components here. And so probably the easiest way to do this, because f of x is kind of big, right? There's 3 terms already. I'm going to figure out what f of a plus h is, try to simplify it, and then plug it in to that big one that I want to find. Okay. One thing to keep in mind is that almost all the time that h in the denominator is going to cancel, right? So it will go away. So if it doesn't, then something happened and you'll have to kind of redo your work. Okay. Not quite. All right, so first I'm going to start with f of a plus h, right, and do it individually. Okay. So f of a plus h is, well, wherever I see an x, I'm just going to put in a plus h, and I'm going to keep those brackets around there, right, because it's acting like one thing. So I've got 2 times a plus h, and then that's squared, right? Remembering that that squared is on the a plus h, right? And so, and then minus 5 times a plus h, and then plus 1. Okay. First thing we're going to have to do is we're going to need to expand that a plus h times a plus h, right? So it's okay to have a little bit of illegal math on the first day, but in general, right, we're going to try to kind of nip that in the bud, because you can't bring that to the power of 2 inside, right, because it's going to behave quite differently. That 5 times a plus h, I can just expand right away. If you want to leave it, that's fine, right? But for me, I'm just going to expand it, just remembering that the negative 5 has to get brought in for both of those, right? So we get negative 5a, and then minus 5h, and then plus 1. Okay, so now I'm going to expand this, right? So a times a, and then plus a times h. I always have a heck of a time when I have to say it. So here, let's just do it. 2, and still in brackets, right? Because that 2 is multiplying this whole thing, right? A squared plus AH plus AH plus H squared. And then the same thing, minus 5A minus 5H plus 1. If you jumped straight to simplifying the AH plus AH to just 2AH, then good for you. That's great. I take the slow route. I usually end up showing way more work than maybe you might want to. 1, because that's how I operate, but 2, because you need to be able to go back and look at my notes and figure out what I did, right? And so it's kind of 2-pronged. But for things like that, if you just went straight to 2a plus or 2ah, then that's fine. So what I mean is 2 times a squared plus 2ah plus h squared. minus 5a minus 5h plus 1. All right. So the last thing I need to do is I need to bring in that 2, right? That's multiplying the a plus h squared. So I get 2a squared plus 4ah plus 2h squared, and then minus 5a minus 5h plus 1. I'm going to simplify this as best as I can. There's not really anything that I can do, though. Right? Do you guys see anything that you can simplify, right? Collecting like terms, things like that. I've got an a squared term, I've got an ah term, I've got an h squared term, I've got an a term, I've got an h term, and I've got just the plain old 1. Right? None of those can go together. So, all right, I guess we're ready to plug it in to the actual thing that we wanted to evaluate, right? We wanted to evaluate f of a plus h, which is actually this whole thing now. And then minus f of a, and then over h. So, let's do f of a plus h minus f of a over h equals, what I'm going to do, because I've already solved f of a plus h, I'm going to put it in, I like big brackets for things like this. That's a matter of taste, I think. Right, so I'm going to put the first term, f of a plus h, in big brackets, and then f of a in another set of big brackets, right? Because then I can see, okay, well, this was f of a plus h, this was f of a, right? And it's just easier for me to keep track of. All right, am I going to run out of room or what? Try to write small. 2a squared plus 4ah plus 2h squared minus 5a minus 5h plus 1 minus f of a, right, is a lot easier, right, because we know what f of x is, so wherever we see an x, I'm just going to plug in an a instead, right? And so for me, because I can't have it all on the same screen, I'm just going to put it down here temporarily, and then I'll erase it. So I get 2a squared minus 5a plus 1. I did it. And that's all over h. It's pretty common that I see, if you have to do this for a long time, right, and you've got it all over h, some people are tempted to just drop the over h, but then they forget to put it in at the end, right? So it's just safer if you just always write out everything that you need, right? It is tedious, but I guess that's math. So, all right. So now I don't need, oops, I don't need this anymore. All right. Each term is expanded. It's as simplified as can be. So now I'm going to bring that negative onto the 5a or f of a, right? Making sure that you bring that negative onto each of the terms, right? And so you get 2a squared, and now I'm dropping the brackets because I don't really need them anymore, right? They were more grouping mechanisms than anything else. So 2a squared plus 4ah plus 2h squared minus 5a minus 5h plus 1 minus 2a squared plus 5a minus 1 over h. Okay. this is looking good, right? Things are going to cancel. And so to cancel things, I'll use a different color just so you can see it, right? But we've got 2a squared minus 2a squared. That's a good sign. I've got minus 5a plus 5a. And then I've got plus 1 and minus 1 that I can group together to make 0. Right. Because that negative was brought onto the plus 1, right? So you have to bring that negative onto each of them. Otherwise, things won't cancel and it'll just balloon out of control, right? And so you want to make sure that you bring it onto all of them. Because now, if we look, the only terms that are left have an h in it, which means we can pull that common h out and cancel the one on the bottom, and we're home free. So just rewrite this: 4ah plus 2h squared minus 5h over h nice. Aha, that'll do it. So now I'm going to pull out the common h. If you want to go ahead, because it's safe to cancel the h because there is an h in each of the terms, right? That's fine. But I'm going to show where it came from. And so we've got h times 4a plus 2h minus 5 over h. That h on the top and the h on the bottom are going to cancel. And so the answer is 4a plus 2h minus 5. Yeah. Oh, what a warm-up. A function warm-up. Okay. So that's a difference quotient, and we're going to use those quite a bit, especially for limits, which we'll start in chapter 2. Limits, no one likes limits, but it's just a hurdle that we have to get through, right? So if you've taken calc before, then you know limits. You probably don't like them. That's fine. I don't like them either, but they're a necessary evil. Okay. So, all right. Domain. So let's do another example, example 6. Find the domain of each function. First one, if we have f of x is the square root of x plus 2. Bless you. Keeping in mind, right, that we can't divide by 0 and we cannot take the square root of a negative number, right? We're not doing any division here, so that's fine, that's done, right? But we are taking the square root, and so we need to make sure that whatever we're taking the square root of is positive, right? 0 or positive. And so we need x plus 2 to be greater than or equal to 0. I'm allowed to take the square root of 0. It's just that the negative numbers that I'm concerned about. Right? So that means that x plus 2 has to be greater than or equal to 0, right? Which means that x must be greater than or equal to negative 2. That's the only restriction on our domain, right? And so that puts our domain, well, it starts at negative 2, and it can be negative 2, right? All the way up to infinity. Okay. And so the domain, is the interval, and I'll spice things up with a little bit of interval notation. Square bracket -2, right? Square brackets meaning it can be that number. Okay. Up to infinity. Round bracket, infinity isn't, it's not a real number, right? And so it cannot be that number, and so we have to use the round bracket, right? And so square brackets if it's included, round bracket if it's not included, right? Up to that point, but not including that. Okay. So how about g of x, mixing it up with a little g function, 1 over x squared minus x. For whatever reason, we typically use starting at f, g, h for functions. I'm not sure why. And then a, b, c for inputs. I don't know why that's a thing, but it is. You can definitely have a of x, but typically not. So 1 over x squared minus x, well, there's no square root, so that's good, right? So there's nothing to worry about there, but we are dividing now, and so we want to make sure that x squared minus x cannot be 0, right? So we want to make sure that we eliminate all the values of x that would result in x squared minus x being 0. Right? That's kind of hard to, we could probably kind of figure our way through it, right? Well, if x is 0, then 0 squared minus 0 is 0. That's out, right? And then if we think about it a little bit, right, 1 squared minus 1 is 0, so that's out. But that's not obvious, right? I don't expect you to sit there and say, oh, well, 0 and 1, they're out, right? Even though if you saw that right away, then that's great, right? But for me, I need to do a little bit more work than that, right? And so the easiest way that I would find, right, would be to kind of factor out that common x, right? And then try to figure out, okay, well, if x is 0, if x is 1, and it'll be more obvious. And so we can factor the denominator. The denominator, remember, is the bottom value. Numerator's on the top, the denominator's on the bottom. And how I just have to remember is the numerator is numero uno, so he's on top. And then the rest is on the bottom, right? And so whatever you need to do to kind of remember all those things, just do it. So we can factor the denominator. And we can see that g of x is 1 over, right, just pulling out that common x times x minus 1. If the original function had been x squared minus 1, for example, then of course, no, you can't factor it, but you also don't need to, right? Because then there's only one option, right? So here, because we've got that common multiple of x, right, then we're going to pull it out. We're going to look at the bottom. So we know that x times x minus 1 cannot be 0. Right? Looking at this, right, we're multiplying two terms, x and x minus 1. And so that means that x can't be 0, and then x minus 1 can't be 0, which means that x would be 1. Right? So, oops. So x cannot be 0, and x cannot be 1. Hey, what's going on there? Something happened with my... Oh. Oh well. See, the lines got all weird? Anyways. Oh well. So let's bring some more notation on you, right? Some set notation. So the domain of G is the set of x's such that x does not equal 0 and x does not equal 1. Right. So here, I'll just tell you how this is read. The set of x such that x does not equal 0 and x does not equal 1. Oops, did a curly bracket again. Okay. So that vertical line is just such that, right? Or even given that. Or if you prefer, interval notation, right? Now we've got the interval from negative infinity to positive infinity, but we have to exclude 0 and 1, right? And so what we do is we start at negative infinity, we go to 0, but we cannot include 0, so we have to use the round bracket. Union, right? Which is or, right? So the union sign we read as or. Or between 0 and 1, but it can't be either of those values, right? So again, we use those round brackets. And then or we pick up again at 1, and then we can continue to positive infinity. Okay. These two say the exact same thing, right? And we need to be comfortable with either way, right? And so, but this chapter is just going to be about reintroducing you to all these things that might need a refresher. Any questions so far? Okay. So let's go back to functions then. And so especially if you've got a graph of a function, right, the easiest way to know if you have a function is you can use the vertical line test, right? Usually we'll have an equation, but if we have a function given in a graph, if we have a function given in a graph, we can use the vertical line test to determine if it's a function. I said it was a function. but I guess it's not necessarily a function if we're checking if it's a function. So if we have I should probably, if we have a graph, otherwise, if we know it's a function, then we don't need to check to see if it's a function, right? So words matter. So if we have a graph, we can use the vertical line test to determine if it is a function. So a curve in the XY plane the XY plane is just the usual kind of coordinate system that we're probably pretty familiar with, right? So that's the XY plane. So a curve in the XY plane is the graph of a function of x if and only if, oops, I almost used the if and only if occurs a lot in mathematical definitions, and so it's abbreviated to IFF, if and only if. No vertical line intersects the curve more than once. Intersects the curve more than once. Should clean up my XY plane a little bit. This is another definition. And it is the definition of the vertical line test. Okay. So for example, if you have an XY plane looking like this, and you've got a curve that goes something like this, right? This would be a function. Right? Because you're able to draw vertical lines at any point and only hit the curve once. Right? So at any point on this curve, right? A vertical line would only hit the curve once. So that's what makes it a function. If instead you have something like, let's say you have something weird going on like this, it's not a function, right? Because at this point here, and this point, and this point, and a lot of other points, right? One input of x gives two inputs of, or two outputs, and that's not a function, right? Remember, the definition of a function is one input, one output, right? So unique outputs. Okay. So this is not a function. All right. Let's talk about piecewise functions. Probably also vaguely familiar. A piecewise function is a function that's defined by two or more different functions for different values of x, right? So depending on where you are for your x, right, that's going to determine what function you're using and thus the output. And so functions that are defined by different formulas in different parts of their domains are called piecewise defined functions. So, just as a little example, a function f is defined by, and to show a piecewise function, we say, well, f of x is equal to, and then we use curly brackets to list all the different functions, all the pieces. F of x in this case is only going to have two pieces. Oops, didn't make it big enough. So I'll do a curly bracket. My left curly bracket is usually pretty good. And then if I ever have to do, because I rarely do, if I ever have to do a right curly bracket, it's brutal. So need some practice. But f of x is going to be 1 minus x if x is less than or equal to -1. And it's going to be x squared if x is greater than -1. Notice that there's no overlap in the x's, right? Because that can't happen. That would give us two outputs for one input. That's not good. So here's our piecewise function. So depending on what x is, clean this up. That's going to determine the function and the output. So we're going to evaluate f of -2, f of -1, and f of 0, and sketch the graph. So just take a couple of minutes, see what you can do. Mm-hmm.
And we use f of a instead of the plus h, and then we solve and get this one. So that's why now I know, because this is really interesting as to know. I will show you result. And this is my first semester method. So if I use f of x plus, so she would take like f of a plus this.
Yeah.
And she put h as just addition, which is
So here, they're doing the same thing, right? Because you're replacing this x with a plus h. So it's 1 over, and then in brackets, a plus h plus 1.
Yeah, this is what I also use. It means they're using this as f of a. This one.
That's right.
Right? Yeah. So same as I did. I get this one is f of a. And this is used here.
Yeah,
that's
fine.
I do it. But the answers to the way, so I got that one also.
Yeah.
It was reasonable. I got that one also. But the answer was totally different.
Yeah, they would be different.
But how is that possible? Because she like the
So yeah, so here,
this is
yeah. So here, see how this x here, for a plus h, you have to replace this x with a plus h, which is what they did here, right? And so, so they're doing the same thing that we did when we did it together. We can talk about it. Oh, do this, and then we can talk. All right. So it's that graph sketching gets a little, ugh, right? So f of -2, oops, go straight to -1. F of -2, well, if x is -2, right, so the input is x. If x is -2, then x is less than or equal to -1, right? And so then I have 1 minus, which is going to be 3. F of -1, -1 is also less than or equal to -1, right? It's equal to -1. And so we still use that same 1 minus x function. So 1 minus -1 is 2. F of 0, though, now x is greater than -1. And so we've got 0 squared as our function. And so now we're at 0. Knowing this, right, we can sketch our graph. It doesn't have to be perfect, but we know a few of the points, right? We know the values of the function when x is -2, -1, and 0. Right? And so we can put those on here. So I know when x is 0, the output is also 0. So that's at 0, 0. I also know that up until this point of -1, right, I'm looking at an x squared function, so that nice parabola, right? And it goes up to x equal to -1, bless you, but not including -1. So I've got this open circle to indicate, hey, it goes up to this point, but it doesn't go to exactly this point. So now I can kind of connect these. That's the best I can do for this parabola here, and that's all right. Remember, we're just sketching it. I guess if I used my lines as a guide. this would be at 1. And I'll put this at 2. Should make it a little bit taller. Three. Oh. How come my parabola only goes to 1, 1 or negative 1, 1? Because if I'm looking at very close to negative 1, right, if I put negative 1 as my x, right, negative 1 squared is 1, right? And so I know that my parabola would go up until that point, and it would behave just like any other parabola up until that very point, right? And then we use the open circle. And then we've got the 1 minus x, which is just a line, right? Y equals mx plus b, that's a linear equation. And so now I can start this at x equal to negative 1, I am at 2, and it's a closed circle. At negative 2, I'm at 3. Oops. And so I can connect these. And it just keeps going. Not convinced?
So we are getting negative 2 at the x-axis.
Yeah, here. I kind of fake put it in. It's just a sketch.
I'm wondering like why we haven't got a 1 graph.
Oh, because like why isn't it one continuous thing? Because it's a piecewise. So if it's like this, then it can have these jumps in it. Right?
You're drawing each one of the answers individually.
Yes, but also knowing that the first one is a line and the second one is a parabola, right? And then I'm kind of extending it. So knowing those things that that I found, right, I can draw those. And we're actually going to talk about the shapes of the functions next day. So we'll do a refresher. But anyways, I know I'm out of time, and I'm so sorry. All right. See you guys. Oh, should I keep the name tags, or are you gonna bring them next day? You don't want me keeping tabs. No, it's good. You guys bring the name tags next day. I don't have your names. Well, no, I don't have them memorized. Anyways, see you guys on Thursday.